When getting weather forecasts, we often hear about air pressure, which refers to the weight of the air in the atmosphere above us. When we stand at sea level on the Earth's surface, we are actually standing at the base of an atmospheric column of air that extends up for about 300 miles, which is where the atmosphere finally fades into space. This newspaper weather map shows H representing an area with high pressure and L for an area with low pressure. What causes an air mass to be high pressure or low?
Air pressure is determined by three main factors: elevation, temperature, and water vapor. As elevation increases, there is less air pressure, because the higher we go, the less atmosphere exists above us. The people in this plane are flying higher than 30,000 feet, an altitude where the air pressure is very low. How do you think the passengers survive at such a high altitude?
The passengers survive because the plane's cabin is pressurized to compensate for the low air pressure outside. Temperature is another factor in determining air pressure. Generally, as the temperature becomes higher, the air becomes less dense. In areas like this rainforest near the equator, under high temperatures, the air becomes heated, less dense, and rises, causing a drop in the area's air pressure. Water vapor also plays a part in air pressure. This is because warmer air holds more water vapor than cooler air. And as vapor is absorbed by warm air, the air becomes less dense and exerts less pressure than dry air.
To measure air pressure, we use a barometer. One type is the mercury barometer. Here, air pressure on liquid mercury in a dish supports a column of mercury in a tube. If air pressure falls, the mercury column drops. And if air pressure increases, the column of mercury goes up. More commonly used today is the aneroid barometer, an airtight box where changes in air pressure cause a needle to move across a dial showing different pressure levels. Keeping in mind the factors we've studied, air pressure can help us predict the weather. From what we've discussed, what kind of weather do you think high pressure often means?
High air pressure often means clear or fair weather, because when large masses of air in the upper atmosphere come together, the air presses down on the lower column of air, preventing warm, moist air from rising into the atmosphere. Under these conditions, clouds do not form, so high pressure often means clear, fair weather. With low pressure, the opposite occurs. When air masses move apart in the upper atmosphere, clouds begin to form as the warm surface air, heavy with moisture, begins to rise. Usually, such low-pressure masses of air are signs of cloudy weather and possible precipitation. Thus, high pressure often means clear weather, and low pressure, cloudy conditions with possible precipitation.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Here's a beaker. When I turn it upside down in the water, there's a bubble of air, and the air pressure is holding the water out. Watch what happens when we go down.
When we were at the surface, there was this much air. The level is right here. As soon as meters down, there's so much water pressure, it's pushed the air up. The same amount of air now only takes up this much room. It's pressure pushing down.
Now, let's take a look at another important factor in causing weather, the winds. Technically, winds are defined as the movement of air from one place to another. We often encounter winds at the beach, breezes that are ideal during the warmer months for cooling off and flying kites. These winds occur because the air above the water is cooler than the air above the hot sandy beach during the day. What happens to this hot air mass over the beach?
Remember, hot air like this rises and becomes an area of low pressure, while the cooler air above the water is more dense and slides under the hotter air. As the air moves from one place to another, it creates a wind effect. At night, it's a different story. As the sun sets, the beach cools more rapidly than the water, and the air above the beach becomes cooler than the air over the water. Again, cooler air moves under the warmer air, and the daytime sea breeze becomes a nighttime offshore wind. The greater the temperature difference between the air masses, the greater the wind speed will be.
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Wind all over the world is caused by heating and cooling of the earth. The wind can do work.
Hey, look at that.
And it makes sailboats go!
Wow, he went right through the door. Hey!
Thanks, guys. Thanks. Whew. Now, real wind doesn't come from a fan. No, in nature, wind is caused by the heat from the sun and the rotation of the earth. That's what makes these intricate patterns of clouds that we see on this photo from space. It works something like this. This is our great big plastic wind box of science. These lights represent the sun. This ice represents the north and south poles. So here's what happens. Energy from the sun heats the land, and the land warms the air over the land. The air molecules get going faster, and they spread farther apart, so they don't weigh as much for the room they take up. So cold air can push the warm air up. That's why we say warm air rises. So look what's happening. The smoke shows us that the air is sinking over the cold poles, flowing over the cities, and then rising over the warm parts. See, it goes around in a great big circle. And that's what happens on the Earth. Now, there's one more thing. The Earth is spinning, so the wind starts spinning. That's why wind comes from all different directions. Wind is wild.
Bill Nye the Science Guy.
Rainstorms, the release of moisture from the atmosphere, are familiar and unpleasant weather events for most of us. But what exactly causes rain to occur? And why sometimes do clear days feel very moist or humid?
The air around us sometimes feels very humid because it contains a great deal of water vapor which enters the air through evaporation, as demonstrated by this kettle. Here, as the water heats, it turns to steam and then enters the atmosphere as water vapor. Water continually evaporates from bodies of water on the Earth's surface, from oceans, rivers, lakes, by means of the sun's radiant energy and wind. Water vapor enters the atmosphere where it is called humidity. Most weather forecasts give a reading for relative humidity, which refers to the percentage of water vapor in the air as related to the amount of moisture that the air can hold at a given temperature. When, for example, the relative humidity is 100%, the air is holding all the moisture it can contain at that temperature. In the atmosphere, warm air can hold more water vapor than cool air. What do you think will probably happen in an area with 95% relative humidity when the temperature is dropping?
As the temperature falls, the atmosphere will reach a point where the air is so filled with moisture, it must be released as rain or some other form of precipitation. This saturation point in the air is called the dew point.
Sometimes at night, on bushes and blades of grass, you may see droplets of water known as dew. This dew appears because warm air holds more moisture than cold air. And as the air cools in the evening to the dew point, the water vapor condenses, becoming droplets of water.
In much the same way, warm air cools as it rises in the atmosphere, while the water vapor it contains condenses on dust and other small particles, resulting in clouds made up of particles and tiny water droplets.
Bill Nye the Science Guy.
Hey, I'm in here. I'm in this giant freezer. Now, let's see what happens when I come outside where you are. See, the surface of my bubble helmet of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day. It's where clouds come from. Where'd you guys go? Oh, funny. Oh, very funny. Anyway, condensation is sort of the opposite of evaporation. Instead of liquid water gaining energy and becoming a vapor, water vapor loses energy and becomes a liquid. Little tiny droplets that stick to cold surfaces. It's a very important thing about condensation. Water vapor needs a place to stick in order for condensation to happen.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
When clouds form, water vapor turns into tiny liquid water drops. But in order for that to happen, the water has to have some place to stick. It has to have something to stick to. So take a look at this. This is our big glass jug cloud apparatus of science. And we're going to make a cloud in here. First, we'll add a little water. This will be the water that will form our cloud. Just swirling it around a little. There. Now, using this pump, we'll pressurize the big glass jug. Then when I pull this rubber stopper off, the air in the jug will expand. And that's when a cloud should form. 3, 2, 1! See, nothing happened. That's because the water vapor didn't have anything to stick to. So what we're gonna do is add some dust. Just a tiny amount of dust. And to make the dust, we'll use the smoke from these two matches. That's all the dust we need to form a cloud. Now watch. We'll pressurize it again. When I pull it off, the air in the jug expands. And when it expands, it cools off. The same thing happens to air masses when they get blown around by the wind and pushed up high into the sky. 3, 2, 1! See? It's a cloud. It's the water cycle. It's science.
Before falling to Earth as precipitation, the water droplets in a cloud must greatly increase in size. A drop of water falling to Earth is usually about 1,000,000 times larger than a droplet suspended in a cloud. Droplets increase in size by colliding with each other and growing until they fall to Earth as rain. When the water droplets fall through very cold air, they may freeze into the ice pellets we call sleet.
Or when the conditions are right, the water droplets can change directly into the crystal shapes we know as snow. Hail occurs when water droplets colliding with ice pellets in a cloud freeze and grow in size. In some cases, falling hail has been observed as large as baseballs.
Large hail can form inside thunderstorms. Thunderstorms have an inflow of warm, moist, unstable air that, because it's warm and moist and unstable, it rises upward in what we call the updraft, which can sometimes exceed 100 miles per hour in thunderstorms. That can allow the hailstone to stay there and grow to very large sizes. But initially, the hailstones begin as tiny water droplets. The air rises, cools into tiny droplets, and then gets to an altitude in the mid-levels of the storm where it's below freezing. At that point, you have a little ice ball that then becomes the nucleus for the formation of growing hailstones that gather these water coatings and then freeze on top of those until the hailstone grows bigger and bigger and bigger with time. It's meandering around in the updraft, being levitated by that updraft as it continues to grow. And because the updraft is so strong, sometimes that can allow for the hailstone to grow to very large sizes. And here you're seeing over 3 inches in diameter. The biggest hailstone recorded in the United States reached a diameter of 8 inches. So sometimes with those violent updrafts, we can get some very large hail, and it can occur in just about any state when conditions become unstable and favorable for severe thunderstorms.